Welcome to the Piping Engineering YouTube channel. In today's video, we will learn simple formulas to easily calculate the center-to-center elbow length, determine elbow degree angles, and find the true length of pipes in a double-rolled pipeline. First of all, thank you to all our members and subscribers for your amazing support. If you'd like to support our educational mission, subscribe or check out our membership packages linked in the description below. Alright, let's dive into today's lesson. To determine the length of a pipe section between two elbows in a pipeline, we will follow these steps. Calculate the overall length and the center-to-center distance between the two elbows. Determine the angle, length of the elbows, and their takeoff dimensions. Finally, subtract the elbow lengths and welding gaps from the overall length. The formula can be expressed as pipe length equals overall length, 2 times elbow length, 2x caps for welding. We will perform all these calculations step by step on this 8-inch pipeline section. Let's denote the overall length or the center-to-center distance between the elbows as L. In our previous videos, we explained that the double rolling part of the pipeline is easier to understand when visualized within a right-angled parallelogram. As you can see, the 8-inch pipeline extends southwards. At the top right corner of the parallelogram, the pipeline first descends by 441 mm, then continues southwards for 978 mm before turning eastwards for 444 mm. Finally, at the bottom left corner of the parallelogram, the pipeline again continues southwards. During the double rolling of a pipeline, two right-angle triangles are formed using dashed lines. We will use these triangles to calculate the overall length, elbow length, and true pipe length. Let's first label the hypotenuse of the horizontal dashed line right-angle triangle with the letter H and then determine its length. To find this hypotenuse, we will use the Pythagorean theorem. According to the Pythagorean theorem, the square of the hypotenuse h will be equal to the sum of the squares of 978 and 444. Using a calculator and find that the square of 978 will equal 956484, and the square of 444 will equal 197136. So, we continue to calculate that h squared will equal 956,484 plus 197136. Using the calculator again, 956484 plus 197136 will equal 1153,620. So, we find that h squared will equals 1153,620. Again, using a calculator, h will equal the square root of 1153,620. It will equal approximately 1074. So, after performing the calculations, we found that the length of the hypotenuse of the horizontal dashed line right-angle triangle is 1074 mm. The hypotenuse of the horizontal right triangle also serves as the perpendicular side of the vertical right triangle. Now, let's label the hypotenuse of the vertical dashed line right-angle triangle with the letter L and calculate its length. To find this hypotenuse, we will use the Pythagorean theorem again. According to the Pythagorean theorem, the square of the hypotenuse L will be equal to the sum of the squares of 441 and 1074. Using a calculator, we calculate that the square of 441 will equal 194481. And the square of 1074 will equal 1153,476. So, we continue to calculate that L squared will equal 194,481 plus 1153,476. Using the calculator again, 194481 plus 1153,476 will equal 1347957. So, we find that L squared equals 1347957. Again, using a calculator, L will equal the square root of 1347957, which is approximately 1161. The hypotenuse of the vertical right triangle also serves as the overall length, or the center-to-center distance between the two elbows. So, after our calculation, we found that we will use the trigonometric function. So, if we denote this angle as A, then A degrees will be equal to the arctangent of 441 divided by 1074. Using a scientific calculator, the arctangent of 441 divided by 1074 will equal approximately 22 degrees. So, we calculated and found that the cutting angle of these elbows is 22 degrees on the 8-inch pipeline. Now we should find the length of the 8-inch 22-degree elbows. We will use this formula to find the length of the elbow, which we have prepared and shared in many videos previously. I will also include the links to those videos in the description below. The elbow length will equal the tangent of elbow angle divided by 2 times 38.1 times the nominal pipe size NPS of the elbow. Now we will substitute our elbow angle and nominal pipe size information into this formula. So, our elbow length will equal the tangent of 22 divided by 2 multiplied 38.1 multiplied by 8. Using a scientific calculator, the tangent of 22 divided by 2 multiplied 38.1 multiplied by 8 will equal approximately 59 millimeters. So, we calculated and found that the length of the 8-inch 22-degree elbow is 59 millimeters in this pipeline. Also, from our other videos, we learned that during fit-up a small gap is required for welding. It should be approximately 3 to 4 millimeters. Now I will show you a small fragment in practice demonstrating how to set the fit-up gap for welding. Please watch it so you can get an idea of the gap in the fit-up. This gap is necessary for a good root weld. Now let's find out true length of the pipe length. Now, we will substitute our overall length, elbow lengths, and welding gap information into above formula. Pipe length equal the overall length 1161 minus 2 times the elbow length 59 and minus 2 times 3 for the caps for welding. Using a calculator, 1161 minus 2 multiplied by 59 minus 2 multiplied by 3 will equals 1037. So, we calculated and found that the red-colored pipe length between the two elbows is 1037 millimeters. By using this method, you can easily calculate the pipe lengths and elbow angles of pipe sections for your desired pipelines. This educational video ends here. Feel free to share your thoughts about the video in the comments section. By joining our channel, you can support us and enjoy exclusive features. If you enjoyed the video, please like and subscribe to our channel. We would like to thank everyone who commented on or liked our work to show their appreciation. Thank you for watching and see you in the next video.
Welcome to our Piping Engineering YouTube channel. We continue our free piping education videos in this channel. Before starting this video, please subscribe to our education YouTube channel to watch more piping engineering videos. You can also benefit from some private benefits by membership to our channel. Let's starting our piping tutorial video. In this video, we will learn what is piping slope and why is it required, how to calculate pipe slope. The standard slope of a pipe is 1/4 inch to 3 inches. Pipes must slope downhill to drain correctly. Proper slope calculation is essential for draining. If not sloped enough, the pipe won't drain. If sloped too much, it won't drain solids. As you can see, this is piping isometric drawing with some slopes and different elevations. In the piping isometric drawings, the slopes are showing with this symbol. In this drawing, slope of the incline is expressed as a ratio of 1 to 100, meaning that for every 1 unit of vertical elevation there are 100 units for horizontal distance. 1% slope denotes 1 unit rise or fall for every 100 units horizontal length or distance. In this case, drain should be down by 1 foot for every 100 length. Let's calculate with slope ration in this example. In this pipe isometric drawing, the slope of the slope at a horizontal distance of 1500 is expressed as a ratio of 1 to 100. 1 to 100 ratio equals x 1500 ratio. Continue. X equals 1500 to 100 ratio. Continue the calculation and found x equals 15 millimeters. This means that the 1500 millimeter long pipeline falls 15 millimeters down at the other end with a slope of 1 to 100 ratio. It is also possible to calculate the slopes in the pipelines with the elevations showing at the turns in the pipeline. In this piping isometric drawing, the initial height of the pipeline elevation is 19,500 millimeters, and the height of the pipeline at the second turn with a slope of 1:100 elevation is 19,485 millimeters. Where the initial height 19,500 millimeters minus the second height 19,485 millimeters equals will be 15 millimeters. With this method we can calculate the difference of the levels in the second and third rotations. Second elevation 19,485 millimeters minus third elevation will be 19,477 millimeters equals 8 millimeters. Let's calculate slope ration now. In this pipe isometric drawing, the slope of the slope at a horizontal distance of 800 is expressed as a ratio of 1 to 100. 1 to 100 ratio equals x 800 ratio. Here x equals 800 to 100 ratio. Continue the calculation and found x equals 8 millimeters. With this method we can calculate the difference of the levels in the 4th and 5th rotations. 4th elevation 19,077 millimeters minus 5th elevation 19,055 equals will be 22 millimeters. Let's calculate with slope ration now. In this pipe isometric drawing, the slope of the slope at a horizontal distance of 2,200 is expressed as a ratio of 1 to 100. 1 to 100 ratio equals x 2200 ratio. Here x equals 2200 to 100 ratio. Continue the calculation and found x equals 22 millimeters. When you want to calculate a slope, you can use both method on the piping drawing. This education video is finishing here. Your comments about video you can write in the comments section. By becoming a member of our channel, you can support our channel and benefit from some features. I would like to express my deep gratitude to our viewers who already have member to our channel. If you liked the video, don't forget to subscribe to our channel. I would like to express my thanks in advance to our viewers who write comments and likes. Thank you for watching. See you on next video. Take care.
Welcome to our Piping Engineering YouTube channel. We continue our free piping education videos in this channel. Before starting this video, please subscribe to our education YouTube channel to watch more piping engineering videos. You can also benefit from some private benefits by membership to our channel. In this video we will show you step by step how to calculate the weight of the carbon steel pipes with easy method. Let's start our education video. The formula for finding the weight of the pipe is as follows. Weight equals volume multiply the density of the material of the pipe. In this formula, the density of the material is taken from the density chart of the materials. We have to calculate the volume ourselves. For calculate the volume we will use this formula. The volume is equals P multiply, in brackets the squared of outside diameter minus the squared inside diameter, divided by 4, multiply length of pipe. This formula belong for all pipe sizes. We will be explaining the calculations in this video on a 10-inch and 16-inch pipe examples. Let's calculate the weight of a 10-inch pipe with a thickness of 80 schedule and a length of 2 meters. To estimating the volume of the pipe piece, let's look at the wall thickness of a 10-inch schedule 80 pipe from the steel pipe dimension chart. This is the steel pipe dimension chart. The nominal pipe size is shown in the first column. The outside diameter of pipes is shown in the second column. The nominal wall thickness schedule is shown in this last column. We will look row shown nominal pipe size 10 inch. The outside diameter of the 10-inch pipe is shown approximately 273 millimeters and wall thickness 80 schedule is shown as 15.09 millimeters. Now we can calculate inside diameter of this 10-inch pipe. The inside diameter will be equals the outside diameter 273 minus 2 times wall thickness 15.09. Using the calculator, we find that the 273 minus 2 times 15.09 will be equals approximately 243. So, we calculated and found that the inside diameter of the 10-inch schedule 80 pipe in our example will be equals 243 millimeters. These dimensions should be converted to meters, because in the density charts of ferrous metals they use meters. Then, outside diameter of 10-inch pipe in our example 0.273 meters and inside diameters will be 0.243 meters. We also know that the length of the pipe is 2 meters. Now let's write this informations we found in the volume calculation formula. The volume 10-inch pipe in our example will be equals P multiply in brackets the squared 0.273 minus the squared 0.243 divided by 4 multiply 2 meters. Using the calculator, we find that the 3.14 multiply in brackets the squared 0.273 minus the squared 0.243 divided by 4 multiplied 2 will be equals 0.0243. So, we calculated and found that the volume of the 10-inch pipe in our example will be equals 0.0243 cube meters. Now let's look at the chart showing the density of iron material. In this chart, iron steel density 7,850 kg/cube meters is shown. Now let's write this information we found in the weight calculation formula. Weight equals volume 0.0243 cube meters multiply the density of the material 7,850 kg/cube meters of the pipe. Using the calculator, we find that the 0.0243 multiply 7,850 will be equals 190. So, we calculated and found that the weight of the 10-inch pipe in our example will be equals 190 kilograms. Now let's calculate the weight of a 16-inch iron pipe with a wall thickness of 160 and a length of 5 meters. Since I know some of the calculations now, I won't repeat them and will move quickly. We will look row shown nominal pipe size 16-inch in the pipe size chart. From the pipe size chart, we find that the outer diameter of the 16-inch Schedule 160 pipe is 406.4 millimeters and wall thickness is 40.49 millimeters. Then, the inside diameter will be equals the outside diameter 406.4 minus 2 times wall thickness 40.49. Using the calculator, we find that the 406.4 minus 2 times 40.49 will be equals approximately 325. So, we calculated and found that the inside diameter of the 16-inch Schedule 160 pipe in our example will be equals 325 millimeters. These dimensions should be converted to meters also. Then, outside diameter of 16-inch pipe in our example 0.406 meters and inside diameters will be 0.325 meters. We also know that the length of the pipe is 5 meters. Now let's write this information we found in the volume calculation formula. The volume 16-inch pipe in our example will be equals 3.14 multiply in brackets the squared 0.406 minus the squared 0.325 divided by 4 multiply 5 meters. Using the calculator, we find that the 3.14 multiply, in brackets the squared 0.406, minus the squared 0.325, divided by 4, multiplied 2, will be equals 0.2324. So, we calculated and found that the volume of the 16-inch pipe in our example will be equals 0.2324 cube meters. We already knew iron steel density is 7,850 kg/cube meters. Now let's write this information in the weight calculation formula. Weight equals volume 0.2324 cube meters multiply the density of the material 7,850 kg/cube meters of the pipe. Using the calculator, we find that the 0.2324 multiply 7,850 will be equals 1824. So, we calculated and found that the weight of the 16-inch Schedule 160 pipe in our example will be equals 1824 kilograms. Summarizing what we learned in this video, we can also use this formula to find the weight of the pipe. Weight is equal to P multiply in brackets the squared of outside diameter minus the squared inside diameter, divided by 4, multiply length of pipe and multiply density of pipe material. By using this method, you can easily calculate weight pipe pieces in the any pipe drawings. This education video is finishing here. Your comments about video you can write in the comments section. By becoming a member of our channel, you can support our channel and benefit from some features. I would like to express my deep gratitude to our viewers who already have member to our channel. If you liked the video, don't forget to subscribe to our channel. I would like to express my thanks in advance to our viewers who write comments and likes. Thank you for watching. See you on next video. Take care.
Dear viewers, if you haven't already subscribed to our channel, we invite you to subscribe and help us reach 100,000 subscribers.
Welcome to our Piping Engineering YouTube channel. We continue our free piping education videos in this channel. Before starting this video, please subscribe to our education YouTube channel to watch more piping engineering videos. In this video we will show step by step how to calculate the distance between the centers of the elbows in the pipeline, the cut elbows length and the length of the pipe piece between these elbows in the 3D model view of pipeline. Let's starting pipe tutorial video. We will perform the calculations in this video on a 5-inch 3D model view of pipeline. To find the length of the yellow color pipe piece between these two elbows, first we must calculate the distance between the centers of the elbows. On next stage we need to find the lengths of the 5-inch cut elbows, and finally from the total length between the centers of the elbows we will subtract the lengths of the cut elbows and the gaps for welding. Let's go step by step. As you can see, 5-inch pipeline comes first horizontal then vertical up with 420 mm and then continue horizontally again. Right triangle is formed with dashed lines after the pipeline rises vertically obliquely 420 mm. The hypotenuse of this right angle triangle is the distance between the elbows in the pipeline. Let's mark the hypotenuse of this vertical right angle triangle with big letter H. Now let's begin to find the hypotenuse of the vertical right angle triangle. We will use the Pythagorean theorem formula in such cases to calculating the hypotenuse of this right angle triangle. According to the Pythagorean theorem formula, hypotenuse h squared will be equals 420 squared plus 770 squared. Continue to calculate the h squared will be equals 769,300. We continue to calculate to find h more easily. H will be equal to 769,300 under the root. At last we will use scientific or phone calculator and found h will be equals to 877 millimeters. So, the overall length between the centers of the butt weld elbows is 877 millimeters. If we subtract the lengths of the cut elbows and the gaps for welding from this total length, we can find the length of the yellow color pipe section. Now let's mark the cut angle of the elbow with A and calculate this angle. In such cases, we will use the trigonometric function formula to calculate the acute angle of this right triangle or the intercept angle of the elbow. According to the trigonometric function, tangents A degrees will be equals 420 divided by 770. We find that 420 divided by 770 equals 0.5454 using a scientific calculator. Using the calculator we find that arctangents 0.5454 will be equal to 28.6 degree. So we calculated and found that the cutting angle of the following elbow is 28.6 degrees. 28.6 degree is one of the acute angle of the right angle triangle. Now let's start calculating the cutting angle of the second elbow on the top. Let's go step by step. Since the pipeline moves in the same plane, let's complete this right triangle into a rectangle. Then this acute angle of the upper right triangle will automatically be 28.6 degrees. 28.6 degree is the cut angle of the top elbow in the same time. Now let's calculate the dimensions of these elbows from the center to the end. Formula for calculating center to end distance of such cut elbows is as follows. Elbow length is equals tangent, elbow degree divided by 2 multiplying 1.5 multiplying nominal pipe size of elbow NPS multiplying 25.4. For this formula 5-inch 28.6 degree but weld elbow length is equals tangent 28.6 divided 2 multiplying 1.5 multiplying 5 multiplying 25.4. We used scientific calculator and found 5-inch 28.6 degree but weld elbow's length is equals 48.5 millimeters. Now look at the pipe fittings fitted in the pipeline. During fit-up there should be a gap of about 3 millimeters between the pipe fittings to be welded. Having this gap is for better root welding. We should take these gaps into account when calculating the length of the yellow color pipe section. If we subtract the lengths of the cut elbows and the gaps for welding from this total length, we can find the length of the yellow color pipe section. Let's start to calculate this yellow color pipe section length. Pipe length is equal, total length 877 millimeters, minus 2 times 5 inch 28.6 degree, but weld elbow length 48.5 millimeters, and minus 2 times gaps for welding 3 millimeters. At last we calculate and found length of 5-inch yellow color pipe section on this pipeline is 774 millimeters. By using this method, you can easily calculate pipe length and cut an elbow to any degrees in the pipelines. This tutorial video is finishing here. If you liked our video, please subscribe Piping Engineering YouTube channel. For help the development of this education channel, is very important our friends supports, likes and comments. Thank you for watching, see you on next video, take care. Welcome to our Piping Engineering channel. In this video, we'll be showing you step by step how to fit up weld neck flanges to the pipe with easy method. Before starting this video, please subscribe to our channel to watch more pipe fitter job videos. Let's starting pipe tutorial video. Before fit up the welding areas of pipes and flanges are chamfered and cleaned.
Deposit photos music.
During fit up weld neck flanges, 2 top holes should be same level.
Deposit photos music. Deposit photos music.
We are checking this with the level.
Deposit photos music. Deposit photos music.
During fit up between pipe fittings should be cap, approximately 3 millimeters, it is for welding. You can see this gap for welding now in this video. During fit up, such are opened between the pipe fittings to be welded, and a gap of approximately 3 to 4 millimeters. Having this 3-4 millimeter gap is for better root welding. After making sure that the top 2 holes are at the same level, we tack weld the weld neck flange to the pipe. And again checking with level top 2 holes. After making sure that the level does not change after the tack weld, weld neck flange tack welding to the pipe by 3 equal places. Now weld neck flange tack welded to the pipe.
Deposit photos music.
Continue to fully welded weld neck flange to the pipe now. In pipe welding, root welding is done first, then hot pass welding, then filling welding, and lastly cap welding. In this video you can see each welding process separately. The welding of the weld neck flange to the pipe is completed. This tutorial video is finishing here. If you have any question about video, you can write comments in the comments section. Your opinions are very interesting for us. You can watch videos about pipe length calculation, pipe slope calculation, piping isometric drawing, welding symbols, pipe fittings, control valves by entering the links in the description below of this video. If you liked our video, please subscribe to our piping tutorial channel. Your support is very important for us. Let's not miss the comments and likes, my friends. Thank you for watching. See you on next video. Take care. Welcome to our Piping Engineering YouTube channel. We're delighted to provide you free piping education videos designed to enhance your knowledge and skills in the field of piping engineering. Before starting video, make sure to hit the subscribe button and turn on notifications to stay updated with our latest videos. First of all, I would like to express my deep gratitude to our subscribers who became members of our channel. In this video, we'll be showing you step by step how to mark and cut 90-degree elbow to the any degrees elbows with easy method. Let's start our education video. In our previous videos, we learned how to mark and cut a 90-degree elbow to a different degree elbow by drawing a template on a workbench. In this video, we will learn how to mark and cut the pipe elbow using only a tape measure. Let's learn how to mark and cut a 25-degree elbow from a 6-inch 90-degree elbow. Before learning the formula for cutting an elbow by any degree, let's learn arc length formula. We know that the formula for the arc length of the circumference S is equals the circumference of circle C multiplied arc degree A divided by the 360 degrees. Also, we know that the formula for the length of the circumference C is equals 2 multiplied P multiplied the outside radius R. So, arc length formula will be S is equals 2 multiplied P 31.4 multiplied arc radius multiplied arc degree divided 360 degrees. Let's simplify this formula a bit. Multiply and divide the numbers known to us in this formula. Using the calculator, we find that the 2 multiplied 3.14 divided by 360 will be equals 0.01744. So the length of the arc, S, will be equal multiplied by 0.01744, the radius of the arc and the degree of the arc. This formula can be used to find the length of arcs of any degree and any radius. Applying this method, we can calculate the lengths of the elbows cut at different degrees from the outside and inside. Let's learn how to mark and cut 25-degree elbow from a 6-inch 90-degree elbow using this formula. We first measure and mark the distance from the outer upper edge of the 90-degree elbow to the length of the 25-degree arc. To calculate this distance, we need to know the radius of the arc according to the arc length formula. If we find the radius of a 6-inch 90-degree elbow, we can easily find the radius of a 25-degree arc. The radius of the 6-inch 90-degree elbow can be found on the elbow dimension chart, or we can calculate it ourselves. Let's first calculate it ourselves and then we can check it with a chart. The formula for calculating the length of 90-degree long radius elbows is as follows. Elbow length in millimeters equals nominal pipe size multiplying 38.1. So, 6-inch 90-degree elbow length will be 6 multiplying 38.1. Using calculator and found 38.1 multiplying 6 will be equals 229 millimeters. Let's check this result with a dimension chart of 90-degree long radius elbows. We can see in the chart, nominal pipe size 6-inch long radius elbow outside diameter is 168.3 millimeters and center to end dimension radius is 229 millimeters. An arc with a radius of 229 millimeters is an imaginary line through the center of a 6-inch 90-degree elbow. As you can see, I have shown it in black color. Also, we know the outside diameter of elbow is 168.3 millimeters. Half of 168 equals 84 millimeters. If we add 84 millimeters to 229, which is the radius of the 6-inch 90-degree elbow, the number obtained will be the radius of the outside blue color arc of the 6-inch elbow. If we subtract 84 mm from the 229, which is the radius of the 6-inch 90-degree elbow, the number obtained will be the radius of the inner red color arc of the 6-inch elbow. So, outside radius of the 6-inch 90-degree elbow 229 plus 84 will be equals 313 mm. Also, inside radius of the 6-inch 90-degree elbow 229 minus 84 will be equals 145 mm. That's good, we are going very well. I hope you are enjoying video. Now, using the arc length formula, let's calculate and mark the length of the 25-degree arc from the inside and outside of the 6-inch elbow. First, let's calculate the length of the blue color arc on the outside of the elbow. So, the length of the outside blue color arc, S, will be equal, multiplied by 0.01744, the radius of the arc, 313 mm, and the degree of the arc, 25 degree. Using the calculator, we find that the 0.01744 multiply 313 multiply 25 will be equals 136.5. So, the length of the outside blue color arc, S, will be equal 136.5 millimeters. Now let's calculate the length of the red color arc on the inside of the elbow. So, the length of the inside red color arc, S, will be equal, multiplied by 0.01744, the radius of the arc 145 mm and the degree of the arc 25 degree. Using the calculator, we find that the 0.01744 multiply 145 multiply 25 will be equals 63. So the length of the inside red color arc, S, will be equal 63 millimeters. In fact, this calculation and marking should have been done on a piece of elbow. I have shown the inner and outer arc lengths of elbow in two places so that it is easy to understand. Now we will delete one of the elbows and make the marking in one elbow. Now we have 2 points on the 6-inch elbow. Connect these 2 points along elbow. This line marked on the 6-inch elbow will be the cutting line of the 25-degree elbow, which will be cut from the 90-degree elbow. We saw that if we write the elbow degree and elbow radius to be cut in this formula, we can easily calculate and mark the outer and inner arc length of the desired elbow. By using this method, you can easily calculate arc length and cut any degree elbows. This education video is finishing here. If you find our content valuable, consider supporting us by sharing our videos and recommending our channel to others. Have a topic you're interested in? Let us know. We're always looking for new ideas to cover. We want to express our deep gratitude to all our viewers who have already become members of our channel. Your support is incredibly valuable to us, and it allows us to keep delivering high-quality content and exclusive benefits. Thank you for visiting the Piping Engineering YouTube channel. We're excited to embark on this educational journey with you.
Welcome to our Piping Engineering YouTube channel. In this video, we'll be showing you how to read bill of materials in the piping isometric drawings, how to easy read the isometric drawings as per arrow directions, and how to calculate elevations in the piping isometric drawings in the 8 minutes. Please subscribe to our channel to watch more like useful video before starting this piping tutorial video. Also, we prepared a 3D model of this pipeline and put the 3D model together with the pipe drawing for you. Easy understand this training video. Let's start first to learn bill of materials for use fabrication of this pipeline. This table is for bill of fabrication materials. The numbers of the materials used in the fabricate of this pipeline are shown in this column. The description of the materials used in the fabricate of this pipeline are shown in this column. The sizes of the materials used in the fabricate of this pipeline are shown in this column. And the quantities of the materials used in the fabricate of this pipeline are shown in this column. Now let's learn the name and number of pipe fittings used in this pipeline. Item number 1 is shown in several places on this pipe drawing. Now let's look at the bill of materials table. Item number 1 is pipe, seamless, schedule XXS, carbon steel, grade 1060, size is 3 inches, the quantity is 3 meters. Item number 2 is shown in 2 places on this pipe drawing. Now let's look at the bill of materials table. Item number 2 is weld neck flange, schedule XXS, carbon steel, grade 1060, size is 3 inches, the quantity is 2 pieces. Item number 3 is shown in 5 places on this piping isometric drawing. Now let's look at the bill of materials table. Item number 3 is elbow, 90-degree, long radius, schedule is XXS, carbon steel, grade 1060, size is 3 inches, the quantity is 5 pieces. Item number 4 is shown in 2 places on this piping isometric drawing. Now let's look at the bill of materials table. Item number 4 is elbow, 45-degree, long radius, schedule is XXS, carbon steel, grade 1060, size is 3 inches, the quantity is 2 pieces. The reading bill of materials in the piping isometric drawing successfully completed. Now, let's learn arrows showing the directions in the piping isometric drawing. Piping engineers to know these arrows well during reading piping drawings. There are 6 directions in the piping isometric drawings. North direction, south direction, east direction, west direction, up direction, down direction. The person reading the drawing should imagine himself facing north, provided that he is in the center of these directions. We will start to read this pipe drawing from this point. The pipeline starts from this flange and extends northwards, a length 197 millimeters. In this point, the pipeline turns to downwards with a 90-degree elbow, and continue a length 343 millimeters. Then, pipeline turns to northwards with a 90-degree elbow, and continue a length 1,533 millimeters. In this point, the pipeline first continue to the northwards a length 143 millimeters, then rise upwards 143 millimeters at angle 45-degree elbow. Then the pipeline extends to northwards with a 45-degree elbow and continue a length 1,365 millimeters. In this point, the pipeline turns to westwards with a 90-degree elbow, and continue a length 577 millimeters. Then the pipeline extends to upwards again with a 90-degree elbow and continue a length 359 millimeters. At last, the pipeline turns to the westwards again with a 90-degree elbow and continue a length of 540 millimeters. And reading piping isometric drawing also successfully completed. Now, let's learn elevations showing in the piping isometric drawing. As you can see, the elevation of the starting point of the pipeline is 20,800 millimeters. Here the level of the pipeline decreased by 343 millimeters vertical and became 20457. We can easily check the correctness of this elevation. 20800 minus 343 equal is 20,457 millimeters. Then the pipeline continued horizontally, therefore elevation not changed. Then the level of pipeline rise 143 mm vertical and became 20600. We can check again the correctness of this elevation. It will be the same 20 meters. Correctness of this elevation. Comments and likes, my friends.